Hello everyone, this is Amir from Audio Science Review. I have another product review, another one of those audiophile tweaks. It's a product called GroundAray by a company called Chord Company. It's not Chord Electronics. It's not the company that makes Chord DACs. Different company, but both situated in UK. It's a low machine aluminum piece. At the end has an RJ45 for Ethernet. You plug it into a switch or router, and it's supposed to reduce the ground noise. Despite being little, this thing costs $800. You can get different versions of it for different unused ports in your computer, in your audio setup. You can get an RCA one, and you can get USB one, and even HDMI looks like, and XLR and so forth. On this thing. Usually I'll lead with measurements for this kind of product, but the people who buy this don't believe in measurements usually. So let's lead with listening test. My everyday workstation is a 16-core Windows PC that I use for listening and running all my measurements and testing. Is fed by a 8-port switch, so I had empty ports to plug this into, and I listen to a range of music while plugging and unplugging this thing. And I gotta tell you, there's absolutely no difference to my ears whatsoever. I couldn't detect any noise changing, fidelity changing. Everything sounded exactly how it should, and it has in the past. So no improvement in subjective listening tests. But someone watching this video is probably skeptical of me thinking that I don't want to hear the change, so I didn't, or I don't have good enough ears. So let's do a more conclusive test, which is a null test, and that's done with a program called Delta Wave. Here I play music through my RME ADI2 Pro, which has a DAC and ADC built into it. So the audio gets converted to analog, and then over XLR cable gets captured back. And I did it twice, once with this plugged into a switch, one not plugged into a switch. And there's also this. You can see that the difference between the two are basically an extremely low noise floor. And we can see that the completed null is about 110 dB or so. And what that means is that the noise floor of the difference is below the noise floor of the 16-bit audio files that I've been playing in here. So there's absolutely no way this can be contributing to any difference in the fidelity of the soundtrack that I had recorded. Now I can let you listen to these samples. I'm going to mute my microphone in between. The idea isn't for you to hear the two samples and be able to tell the difference yourself. I'm going to keep them very short, but I will then play the null file, and you're welcome to turn up the volume and see if you can tell what the whether there's any sound coming out audibly, forgetting about the spectrum of it. So this is Delta Wave again. So, I'm going to go ahead and mute myself and play the first sample. That was sample number 1. Here's sample number 2. And this is the null difference now. You're welcome to turn up the volume and listen to it. So I'm back. I don't know if, because of compression that's used in YouTube, whether there's some noise modulation that may be there in the YouTube video. I'll listen to it later on. But you're welcome to get this file through Dropbox, and then you'll have the pure digital version of this that you can listen to yourself. Let me go back to review, and here's the Dropbox link, and you can click on it and listen to it directly in Dropbox. It's able to play WAV files, or you can download it and mess with it. With these very sensitive IEMs, I can boost the levels about 40 dB above my comfortable listening levels. When I'm listening to this null, I absolutely hear silence. There's nothing there in there to contribute to any difference between the two. So as far as the subjective test is concerned, using our ears and using our brain, there's absolutely no difference that is made to my setup at all. So But let's be more accurate and use our measurement and instrumentation, because we can measure much better than our hearing threshold. When I first got into this test, I thought the two Chord companies were the same. So I still have the Chord Dave DAC, a $14,000 DAC, and I thought I'd use that to match the two so there would be no complaint about resolution of the device. But turns out they're two different companies. Still, this is a high-end DAC, and if a $14,000 DAC doesn't show a difference, then hopefully folks will agree with the results. So this is a Chord Dave DAC by itself being measured, playing a 1 kHz tone. There's a distortion over here at minus 125 dB, so 15 dB below threshold of hearing when we have no trouble or 10 dB below threshold of hearing, and we have no trouble measuring that. We also have tiny little spikes in here that are around minus 140 dB, and we have no trouble measuring those. But let's plug in the ground array, and we see those little ticks are still here, and this distortion has not changed one bit. There's no jitter components in either case to remove, and if you see tiniest variation in here, it's just because of run-to-run variation. Output voltage is the same, down to 3 decimal places, and distortion noise is the same. But let's focus on noise alone. And because that's the company's claim, and with that we measure our dynamic range, difference between DAC playing nothing to playing the maximum volume, and we see that the result with or without this ground array from Chord plugged in is basically the same. There's a bit of run-to-run variation. One channel of Chord DAC is less stable, and it does vary a little bit. But the second channel, we see that it's accurate to even 3 decimal places, even though we usually don't look at these numbers that accurate. There's a criticism commonly that, hey, you're only playing a single tone at 1 kilohertz. Maybe there's a difference with real music that has more tones. Okay, we use 32 tones, and we quickly see that there are intermodulation distortions coming from this DAC, low-frequency ones, likely from power supply, but it could also be on the ground of USB connection to the DAC. And but when I plug in the ground array in there, it makes no difference. These are two measurements, one in blue, one in red. They're landing right on top of each other, so there's absolutely no difference. Now, I want to make sure you understand what this device is. This is not an electronic filter. There's no circuit that's completed whatsoever. All of these grounding products, they literally just connect to the chassis of your audio equipment, and they come out with a piece of wire, and that piece of wire is then suspended inside with some special material that they filled this thing with, and you can get a box that's this big with a similar kind of idea from a company called N-Trek, and there are other ones that make these grounding products. And the idea is that you can suck noise out of the ground of your computer, of your audio equipment. The ground can be polluted in audio equipment, hence the reason you should use balanced XLR if you can. But if you're using RCA, yes, that can become part of the signal. Whether it's audible is a different thing, but if the noise is there, there's nothing in physics that tells you this is able to do anything with that, because electrons, they're basically as a noise signal, have no desire to go into something that just sits in the vapor like this. It wants to complete a circuit, and then electrons will flow. If you take a light bulb, connect to one side of a battery and not the other side, the light bulb does not come on, right? So electrons don't want to just go to nowhere. And they happily go between your piece of equipment and not care about going to something that just hanging in the air with high impedance. So the fundamental principle that these grounding products are able to drain things from your ground is wrong. As a matter of physics, as a matter of basics of electronics, that kind of thing does not work. Company says this then generates that to heat, converts it to heat. That works with vibration, but does not work with an electrical signal like this. On top of that, in a switch as I'm using, the ports are independent of each other. A network switch and Ethernet switch means I can have port 1 and 2 communicating, and a port 8 where I've plugged this in there has nothing to do with those two other ports, is both logically and electronically isolated from this other port that is plugged into. And indeed, there are transformers in there that have an air gap in there that make sure that the two circuits grounds are not coupled together when you use Ethernet, because you could have Ethernet cable go hundreds of feet between buildings, and you don't want to have ground loops causing problems. So the whole fundamental idea of this cannot and does not work, and we've shown with measurements and listening tests it doesn't work. Now, the company, if you listen to, they have testimonials. They've taken to audio shows, plugged this in, and wow, everybody said, fidelity was improved. How can that be? Are those people delusional? No, they're not. As I've explained many times, You have a system, you play some music, then you say, look, I'm going to now plug this in there, and all of a sudden all the brains become like a microscope, focusing and zooming in, trying to hear differences. And when you plug this in, indeed, you will hear differences, because your brain starts to filter out a lot of the music, tries to take it apart and focus on smallest detail. Whatever you think your idea of high fidelity is on imaging, detail, noise floor, the brain becomes an instrument and focus on those things, so it hears different than it did when you were just, okay, there's some music music playing, so what? And then you plug this in, wow, it made a difference. The problem is that later on, after you bought this, you plug it into your system and you sit back and listen, your brain's no longer doing that kind of parting of the waves and doing that analysis, is able to now just relax and listen, and this device will no longer have that false impression on you and will do nothing. If you disagree with me, turn on your cell phone video, have a loved one switch this or not switch it 10 times, and see if you can get 8 or 9 times out of 10 accurately identify whether it's plugged in or not. We need the video so we can see if you could see what's going on. We need some documentation. We need to know how the whole thing was set up, where the sequence random. Please don't come back and say, oh, I plugged in, unplugged it blind, and I could tell the difference. 1 time doesn't mean anything. Twice doesn't mean anything. 3 times doesn't mean anything. I've done these tests where 4 or 5 times I was right, and then 50 times I was wrong after that. So, you can get like a few times in a row, just like flipping of a coin, but you need to run it enough times so that we know that it's a statistically reliable thing. Unfortunately, if it doesn't work, you're out $800. So please don't spend your money on this kind of thing. Okay, see you in a future video. Bye-bye.